Hello, I'm Harshita, and today I'm gonna be explaining Warshall's algorithm and Floyd's algorithm. Firstly, let's see what is a Warshall's algorithm. According to the definition, we can see Warshall's algorithm is a graph analysis algorithm used to find the transitive closure of a directed graph, determining whether there is a path that is between all the pairs of the vertices. Basically, what it means is if you assume I as a source node and J as a destination node, we are simply checking if there is a path that is existing directly from I to J, or we will see if there is an existing path from I to K and K to J. That is simple. We are seeing if there is a path that is directly existing from I to J, or through an intermediate to node that we are seeing if there is a path that is existing. Okay, so the algorithm goes like this. We are traveling through the loop thrice, and the formula that we are implementing to find if there is a path that is existing is just direct or operation directly can be traveled from I to J, or through an intermediate node can be traveled, that is using AND operation can be traveled. So the return value will be the Boolean expression. So since we are checking only if the path is existing or not, so the answer will be in the form of zeros and ones. So yeah, let's take a quick example. So if you take I'm pretty sure like everybody knows how to convert a directed graph to a matrix. So what it says is like yeah. So let's after conversion, this is the graph that we get. This is the matrix that we get. So according to the Warshall's algorithm, we need to check through each node if there is a path that is existing through that node as the intermediate node. So here we have taken A as an intermediate node. Let's see from B to B if there is a path that is existing. So let me just take a yeah. So according to the formula, what they are saying is if there is a path that is existing from B to B directly, no, but or operation. But let's see if there is an existing path from B to A and A to B. That is B to A, is there a path? No, zero. And sorry, A to B is there a path? One. So if you know the logical operation, you know that 0 and 1 would be 0, and 0 or 0 will be 0. So that change is implemented here. And B to C, if you check again, it is there a previous path? Like, is there a direct path? No. Is there a intermediate way that we can pass? No. Again, there is nothing. And then let's see for D. So B to D, there is already an existing path from B to D directly. We don't have to check for intermediate B because there is already an existing path, so you can skip that. So that is how you find whether the path is existing. Similarly, this was for A as an intermediate node. Here we will check for B, C, and D, and finally we will get this as the matrix. Okay, we'll iterate all the way through by considering A, B, C, D individually as an intermediate node, and we will find the answer. So yeah, so this is the formula basically we will use. We have used in the by to understand the what is it, the Warshall's algorithm. So yeah, and the time complexity will be big O of n cube because we are entering the loop thrice. So yeah, simply said that. So what is the Floyd's algorithm? Floyd's algorithm is a modified version of the Warshall's algorithm, because in Warshall's algorithm we are just checking if the path is existing or not. Here we will find the distance, that is the shortest distance between the nodes. Okay. Again, let me repeat. In the Warshall's algorithm, we are checking from node to node if there is existing a path. Okay. Here we will see if there is a shortest distance will calculate the shortest distance between the each node. Okay, let's see how we can see that. So let's just simply take an example. Let's say this is I and j is a direct node. I to j, let's say 5 is the distance. So again, k is the intermediate node we are taking. Let's say I to k, the distance is 1, and k to j, the distance is 2. According to the formula, according to the Floyd's algorithm, you should see if the minimum is minimum between the direct node. Minimum between the direct node, like the direct node, the distance is 5, or from intermediate node it is 1 plus 2. According to the formula, we need to check the minimum. Which is the minimum? Obviously 2. So sorry, obviously there is 3. Sorry, it is 3. So through an intermediate, if you travel, it will be short and it will be optimal. So that is what it is saying according to the Floyd's. So this the algorithm is like this. We will take the minimum distance between the direct node or the addition, the sum of intermediate nodes. Let's take a quick example that is from, we are converting a directed graph to a matrix here. So yeah, according to the formula, that is minimum. We will just take the formula and write it. Okay. So yeah, and this is the OR operation. Yeah. So yeah. Here we have considered A as an intermediate node. According to the first one, we have considered A as an intermediate node. Let's see from how can we travel from B to B. B to B directly we can take, directly it is said that 0, you can't travel. So let's see from, like, can we travel from B to A and A to B? As of like taking an intermediate node, can we travel? So B to A is 2, okay, plus A to B, what is it? Infinity. So according to the formula, what we have to see, minimum, right? Which is minimum? 0. So we will consider that okay, the change is implemented here. So we are considering 0 because 0 is minimum. So similarly, let me just erase this and yeah, okay, let's see this one. So let's see how can we travel from B to C and how much is the distance. B to C previously existing, they say it is infinity according to the matrix. Can we travel from B to C through A? Let's see. B to A we can travel with a distance of 2 plus A to C. How much can we travel? 3. So which is smaller, infinity or 5? 5 is smaller, right? So we will be considering the smallest distance according to the formula. So I hope it is clear. We are taking the smallest distance from B to C. So B to C smallest distance is 5 and we are considering that into the matrix. Okay. So let's move on to the next one, that is B to D. Okay. So B to D according to the form, B to D according to the matrix, what is it? Directly if you take, it will be infinity. What about indirectly, that is using A? B to A is, we can say 2 plus, and D, A to D would be infinity. It's smaller, infinity or infinity plus 2. Yeah, infinity only is smaller because infinity plus 2 would be greater, right? So infinity plus infinity is considered and it is implemented here. So we will again do that entirely considering B, C and D as an intermediate modes, and we will be finding this as the final matrix that gives the shortest distance among the each nodes. Okay, simply said, we're moving on. This is the formula that we have used, that is to summarize what I have taught you. And the time complexity is big O of n cube because we are entering the loop thrice. Rows, that is once is rows, like columns, then there is the each node. Okay, so that is why that is big of. And so yeah, before ending the video, I'll just summarize what we have learned in the Warshall's algorithm. The definition goes like this: we are seeing from one node to another node if the path is existing or not. That is all. In the Floyd's algorithm, we are seeing if the path is existing. Also, we are checking with the also we are calculating the smallest distance between the each node. Okay. So simply said, that is the definition, and for both of the term complexity is big of n. So yeah, this was the entire video, simple and it is easy to understand. Hope this was helpful, and thank you.